I am going to work through the quiz 7 so you guys can see that. But if you have not tried the quiz 7 first, you need to go back and do that before you watch this video. So, on your honor there. You need to try it first. Make sure you're really giving yourself a chance to think through it and maybe struggle with it for a minute. All right, so looking at our first one, we have a subtraction. So change this to adding the opposite. Change this to adding the opposite. So that when I go through and do the subtraction in the second set of parentheses, I will change those signs as needed. Dropping the first set of parentheses because I don't need it anymore. And then see each thing inside the second set of parentheses, we're just going to change the sign. So it was a positive x cubed, so now it's going to be negative x cubed. It'll be a negative 7x squared, and then a positive 9x. And once we have done that, now it's all addition. We can shuffle things around to find the like terms. So if I look at like the x cubed, there is another x cubed term. When I add those two together, we'll get 4x cubed. Then if I look at x squared terms, there's one there and one there. So I can add those x squared terms together and get a negative 8x squared. And then looking at the x terms, I have a 3x and a 9x, so adding those together would be 12x. So this answer would be fine for me. For Alex, it would prefer it if you put it into this format, where we have a subtraction instead of adding the opposite for the 8x squared term. So 4x cubed minus 8x squared plus 12x is going to be the answer for the subtraction for that. Number 2, multiplying the binomials, 2y plus 6, and the second binomial is y minus 4. So I'm going to go through and FOIL that. So I'll have 2y times y plus 2y times a negative 4 plus 6 times y plus 6 times a negative 4. And that's just the simple foiling, and then we need to do some cleanup. So we'll have 2y squared minus 8y plus 6y minus 24. And then those middle terms are like terms, so we can add those together. So 2y squared minus 2y minus 24 would be the best answer for this one. If you had those as adding the opposite, that would be fine for me. And just know if you're doing the homework that Alex is perhaps not going to like that. All right, the next one, number 3, we have one set of parentheses is z minus 8. The other set is z plus 8. So this is one of those special patterns. So if I recognize that, I know that it's the a minus b, a plus b pattern, which means I could go right to a squared minus b squared as my answer. And if you don't recognize it, just FOIL it out, and it will end up being the same thing. So z times z plus z times 8 plus z times negative 8 plus negative 8 times 8. And then what's going to happen there, once we clean that up, we'll have a z squared plus 8z minus 8z minus 64. And remember, this is that situation where those middle terms drop out. That's why we can say it's a squared minus b squared if I'm using the shortcut. So z squared minus 64 would be the best answer. And we can see it is a difference of squares now. Number 4, we have y plus 7 quantity squared. And remember, that means we're going to take that entire binomial and we are multiplying that by itself. There is a shortcut for this one. If you have a plus b quantity squared, that will be the first term squared, the last term squared, and then the middle term is twice the product of those two. So it'd be 2ab there. But you can always just FOIL this out and you will get to the same place. Now, it's a binomial that is repeated, so it is not the same as number 3. So we have y times y plus y times 7 plus 7 times y plus 7 times 7. So getting some simplifying going here, we'll have y squared plus 7y plus 7y plus 49. And then those middle terms are like terms, and they add together instead of canceling each other out. So they end up actually doubling there, right? We get 7y and 7y. That doubles to 14y. So y squared plus 14y plus 49 would be the best answer for this. And when I'm saying best answer, remember that that means it's in descending order. I'm using subtraction instead of adding the opposite, you know, all that kind of stuff. So, and you might have something slightly different than your neighbor. It doesn't mean that either of you are wrong. All right. Flipping over. I'm going to skip 5 for the moment. Let's look at 6 and 7. So 6, we're looking at simplifying with those exponent properties. And we've got a product of powers on the first one. So remember that that's going to be 18 to the 4 plus 7 power, because this would have 4 terms of 18 and this would have 7 terms of 18. So altogether we're going to have 11 terms of 18 that are multiplied by themselves there. The one in the middle, this one is a power of a power situation. Notice the difference here is you only have one base here, and you have the parentheses, and the entire chunk is taken to that power. So now we are going to actually multiply those powers. So it'll be to the 4 times 7 power, or 18 to the 28th power. And we're practicing the exponent properties, so don't figure out what these are in terms of scientific notation. I just want them as 18 to some power. And then part C, we have a quotient of powers. Remember, that's where we are going to subtract the powers. So if we multiply them together, we add the powers, we're dividing them, we are going to subtract the powers. So 4 minus 7. So here we would get 18 to the -3, but we can't leave it as a negative value for that exponent. So we are going to take the reciprocal by putting it in the denominator. And then since we took care of that negative portion of the exponent, that is now gone, and I just have 1 over 18 cubed. And number 7. Given the following polynomial, answer the questions. Okay, so we have 3 terms. So as far as type of polynomial, that's going to have to be a trinomial. For the degree, you're going to need to figure out what these are. Now remember, you're going to have to add them together if you have the 2 or more than 1 variable. So for this term, the degree would be 3 plus 1 or 4 because of the x cubed and the y to the first. For the one next to it, we're going to have 2 plus 7 or 9 for the degree on that term. And then constants, remember, are degree 0. So constant degree 0. So the highest one is going to be what determines the degree of the entire polynomial. So we're going to take that 9 from that's the term that is listed in the center. That term is also going to define which one is our leading coefficient. So that term being negative 5x squared y to the 7th. So the coefficient on that is negative 5. And then the constant, so just remembering that your eyes aren't glossing over the subtractions here, that constant would be a negative 10. So the one that does not have a variable on it. So these pieces of information should mostly just be being picked out. We had to do a little work here to figure out what the degrees were for those terms. But other than that, this is just choosing carefully from the information that we have in the polynomial. All right, now we're going to go back up to the top of this page and look at number 5. So, the path I walk my dogs is triangular in shape with a distance of 12,000 feet total. The first side is represented by X. The next side is 1,000 feet longer than the first side. The third side is 1,000 feet less than twice the first side. What are the lengths of each side of the path? All right, so I do recommend, sketching yourself a little picture here. You don't know what kind of a triangle it is. It really doesn't matter. It just is a way for us to look at these pieces of information in a little bit more graphical way, and that can sometimes be all that you need to pull the information together. So we are given that the perimeter is 12,000 feet. Remember that perimeter for a triangle, we're just adding those 3 side lengths together. So we're trying to figure out what are we going to use for A, B, and C here so that I only have one variable, because I don't know how to solve these if they have more than one variable. Now, in the different sentences here, you're going to get those pieces of information. So the first side is represented by X. Okay, so we'll call this one X. The next side is 1,000 feet longer than the first side. Okay, so if it's 1,000 feet longer, we're going to be adding, right? That's a translation code word for adding. So it's going to start with the first side, but then it's going to add 1,000. So X plus 1,000 would be that side. And then the third side is 1,000 feet less than twice the first side. 1,000 feet less than twice the first side. Okay, so twice the first side, that's our math code word for multiplying, and specifically multiplying by 2. So we'll have 2 times the first side, which is X, and it's 1,000 feet less than that, so we are going to subtract 1,000 from that 2x, and that will give us our third side of our triangle. And then once we've got those 3 things translated, we put all this information together into the perimeter area formula. The perimeter of a triangle formula, not the area formula. All right, so then we've got the 12,000 equals, and then we're going to have X for the first side, and then X plus 1,000 for the next side, and then 2x minus 1,000 for the third side. So the big mistake people tend to make here is they forget to put all 3 sides. So make sure that all 3 sides are represented here. You can see I've got it matched back up to my picture, that I've got that side X, X plus 1,000, and 2X minus 1,000. Those are the 3 things I'm going to add together. And then from there, you can go ahead and do the solving on that. So this would be actually end up becoming 4X over here on the right is going to be 12,000. So then X would be 3,000. Now remember that's going to be feet, because it is that length. So the first side is 3,000 feet. And then to get the other sides, we need to substitute in. So we're going to say that thing plus 1,000 is going to be the next side. So we'll have the 3,000 plus 1,000, or 4,000 feet for the next side.